Hello everyone, welcome to Reactify Labs. Today we will do the problem construct binary tree from pre-order and post-order traversal. Okay, so the question says that we are provided with the pre-order and post-order traversal of binary tree. So this is the pre-order traversal of a tree and this is the post-order traversal of a tree. From these two traversals we have to create a tree. Like what will the binary tree look like? So if you do not remember or if you don't know what pre-order traversal is, so pre-order traversal is root left right, first root then left then right and recursively, right? And post-order traversal is first left child then right child and then root is traversed and recursively. So let me explain with an example. So let's say there is a tree 10, 20, 30, 25, 26, 32, 33. Okay, so as I said, pre-order traversal first root. Okay, so this root will come first, 10. Next is left child. Left child means 20, but what exactly in 20? In the left also we will do recursion again. So recursion means again root. So root of the left child. Okay, now again once the root is done we will go left. Left is now 25, so it will be 25, and after left what is right? So 26. Now it will go back here, it will go back here, root is done, left child is all done, now right. So when we come here at the right, again in the right the recursion will come for the root. So root means again 30, then the left child of 30 and then right child of 30, so 32 and 33. So that's how pre-order traversal is done. Okay, root left right. And what about post-order traversal? So the post-order traversal is now like this. So the post-order traversal will be first left then right then only root. So, and again as I said, all in recursive manner. So first we have this root, we will go to its left child. Okay, again does it have a left child? Yes, again we will come to 25. Now does it have a left child? No, so left is done. Does it have a right child? No, so right is also done. So now the root will be printed and root is 25. Okay, now what? After left root, after this the call will go here and it will come to the right. And 26, does it have again recursion? Does it have left child? No. Does it have right child? No, so the root will be printed. So it is 26. And now for 20 both left and right child are done, so now 20 will be printed. Okay, so 25, 26 and then 20, and now the call will go to this. So now we see that left child is all done, so the call will now come to right child. Again in the right the recursion will come, it will first check the left child, and so it will print 32, then 33, then 30, and after all this is done the call will go back to root and 10 will be printed. Okay, so basically if we have or if we are provided with this pre-order and post-order traversal, we have to create this kind of tree. Okay, so similarly from this pre-order and post-order traversal, what kind of tree will be formed, we have to find out. How can we do that? It looks like a tricky question, but it is not. If we observe a few things, we will notice that there is a pattern. The pattern is, you see, the root is present here. So the first element of pre-order is root, and the last element of post-order is root. Last element of post-order is root. I hope everybody agrees with this point. Okay, so now we know that okay till that point it is fine. Whatever happens, the 10 will become the root. Okay, let's remove this tree or let's make another tree and we'll try to match them. Okay, so if you see 10 will definitely be the root, there is no doubt in that. Okay, so 10 will be root. Now what? Now if you see, in any case the left side, whatever comes in the pre-order traversal, whatever is next to 10, okay, whatever is next to root, that will definitely be the left child of 10. Okay, but here it gets a little messy. Okay, we cannot directly do that. We can, yes, the obviously 20 will be there, but can we use it for something else as well? Okay, so if you see this 20, we know that 20 is the left child, right? So it means for 10, if we have to fill the left child, obviously it will be 20. Okay, but now if we utilize this 20 and try to find out this 20 here, okay, if we try to find out this 20 in post order, we will notice that whatever is towards the left of 20 are its left and right children, right? I hope everybody agrees to it. If they had more children, it would be more, but right now 25 and 26 are the children of 20. So we can easily do this, like for 20, this will be 25 and 26. Now what? Now we know that 20 and its children are done. Now we come to 30. And again, when we find 30, we will see that numbers which are towards the left of 30, but after this 20, because this 20 is its sibling, right? So the number which is between these 20 and 30 are the children of 30, right? So 32 and 33. That's how we construct the tree. It looks easy. The code is a little complicated because it involves recursion, right? The code involves recursion. So that's why it might seem a little complicated, but if you understand this concept, this will be clear. So let's try to create a tree from our given input. Okay. Since you can say that since I already had this tree, it was easier for me to explain and for you to visualize. So let's make a tree from what we do not know. As we see, this and this are same. It means 1 is definitely the root. Okay. Now the left child of 1 is the rightmost, or the immediate right element of 1 is its left child. Agree? We will find this 2 here. Okay, we found this 2. Now whatever is towards the left of it is its children, 4 and 5. Okay, now what? Now we know that 2, 4, 5 are done. Okay, now which element will come? This 3. 3 will be the right child of 1, and whatever is towards this left of 3 are the children of 3. So this is what our binary tree will look like, which are constructed from this input. Okay, so let's take a little more complicated example. I know this sounds very simple, so but I don't have an input as such. So what I will do is I will make a tree first. Okay, I will make a tree intentionally hard, and then I will try to make a similar tree from its post order and pre-order traversal. Okay, let's say this is 1, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9. Actually, limited space basically is causing the problem. 10, 11, 12, 13, 14, 15. Okay, this is one more level deep. So if we have to write the pre-order traversal, as I mentioned, what is it? It is root, left and right. So root, now left, and what next? Left again, 4, now 8, 9, 5, 10, 11, right? All of the root and all the left children are done. Now we will go to right. Right is again now 3, 6, 12, 13, 7, 14, 15. Okay, and now we have post order traversal. Post order is left, right, root. So it will start with 8, 9, 4. Then 10, 11, 5. So left is done, right is done. Now root means 2. Now again 12, 13, 6, right? Next is 14, 15, 7. Next is 3, and next is 1. So we have our pre-order and post-order ready. Now let's try to construct a binary tree from this. Again, we will use the same thing. The root will be the first element or the last element, right? First element of pre-order or last element of post-order. So it will be 1. Okay, the immediate next element in the pre-order is the left child. Okay, so now we will find this 2 here. So we'll find this 2 here in the post order. We have found this tree, we have found this 2 basically. Now everything towards the left of 2 will be the children or grandchildren of 2. If you see 8, 9, 4, 10, 11, 5, 8, 9, 4, 10, 11, 5, all are the left children of it. Okay, but can we directly do as we did in previous example? Yes, we can. But the thing is, in the last example, it was easier to visualize that, okay, there was no child. So since there was no other child of 4, we could take it like this. But as I said before, we are using recursion. We will be using recursion. So every time that we come at the next node, we have to check for recursion. Okay. So when we come to 4, 4 also has children. So now we know that the immediate next element of 2 is the child of 2, right? So now we have 4. So now we find 4. We found 4. So now these 2 elements are the children of 4, 8 and 9, right? Now 4, 8 and 9 are done. Next element is 5. When we find 5 here, we see that 10 and 11 are children of 5, right? So this is how we will do. This is how recursion is involved. Now we are done till this point. Okay. And in this case, we are done till this point. Now we will start with 3. We know that 3 will be the right child of 1, definitely, right? Because left is all done. So now we find 3 here. And when we find 3, we know that all of these starting from 2 till 3 will be in the children or grandchildren of 3. Now, immediate next to 3 is 6, which is the left child of 3, right? So we find 6 here, and we see that when we find 6, 12 and 13 are its children. So 12 and 13. Similarly, next element is 7. 7 and towards its left are 14 and 15. Sorry, 7 and 14 and 15. So that's how it is done. So that's how we have constructed a tree from the pre-order and post-order traversal. I know it's a little bit messier or a little bit harder to visualize recursion. It's not it's not new. It's like everybody at one point in their time in their life have struggled with recursion. Even I have struggled with recursion. I still do in some complicated recursion cases. So I would suggest keep on practicing. With practice, it will come. It will become easy, and you will be able to visualize more as you practice more. Okay. So I would suggest that now you understand the logic, try to write the code by yourself. If it's like you cannot write the code, then the solution link is in the description of this video. Please refer to it. But I highly encourage you to try writing the code by yourself. You will learn a lot better that way. Okay. This will also help you understand this will also test you that is it possible for you to convert a logic into the code, that you know the logic, but can you convert it into a code? So yeah, there are a lot of benefits of writing your own code, but in case you fail to do it even after trying very hard, just please refer to the code in the description. So yeah, I hope you like this video. I hope this video was helpful to you in understanding how to construct a tree from pre-order and post-order traversal. If there are any doubts, please let me know in the comments. And yeah, that's all for this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.